Question number 7 is a maximum minimum question. We actually want the minimum distance of a line segment. So I need an equation for the distance. I need to take the derivative and set it equal to 0. I need to solve for x and then answer the question. So they're the things I need. So how am I going to come up with those? I need to read the question and use whatever formulas I know. So point lies on this line, so it has a y-intercept of 3 and a gradient of a half. So it goes down 1/2, down 1/2. So it goes over here to -6. So there is my line. I've got a point P somewhere on this line. So point P on this line will have x and y coordinates. If its x coordinate is x, the y coordinate is a half x plus 3. And I've got my 0. I'm looking for this distance here of OP. Let's call OP equal to D for distance. So D will equal, I'm going to use the distance formula, which will be y2 minus y1 squared plus x2 minus x1 squared, which will be the square root of y2 is a half x plus 3 minus 0 squared, because this is y2 at 0, 0, plus x minus 0 squared. So we've got the square root of, expanding this perfect square, a half x squared is a quarter x squared, plus 2 times the first times the second is 2 times a half times 3, or 3x, plus 9 plus x squared, which gives me 5 on 4x squared plus 3x plus 9 is the distance from O to P. I need to find out where that is going to be a minimum, because obviously I could have P over here and that length is much bigger than this length, or it could be up over here, but there is a point somewhere over here where the distance is the shortest possible distance. So I need to take the derivative of this. I can make two choices. I can clean this up and turn it into the square root of 5x squared plus 4 3s are 12x plus 36 all over 4, which is the same as a half the square root of 5x squared plus 12x plus 36. Or I can leave it as this. And I'll show you get the same answer for both of them. If that's what d equals, then dd dx, the derivative, will be, I have a half, I've got this thing to the power of a half. So it's going to be a half times that thing to the power of negative a half, times the derivative of the inside, which is 10x plus 12. And what does that look like? That looks like 10x plus 12 on top of 4, the square root of 5x squared plus 12x plus 36. And that's going to equal 0 only when the numerator equals 0. Therefore, 10x plus 12 equals 0. 10x equals negative 12. X equals negative 6 on 5. If I was to choose this one, then I would do the same thing. dd dx is going to equal, I have something to the power of a half. It's going to be a half times that something to a negative a half. Then I multiply it by the derivative of the inside, which will be 2 times 5 on 4, 5 on 2x plus 3, which will equal 5 on 2x plus 3, the 2 goes downstairs, This goes downstairs. And that's going to equal 0 only when the numerator equals 0. So 0 equals 5 on 2x plus 3. 5 on 2x equals negative 3. X equals negative 6 on 5. Not a coincidence that it's the same answer as I got over here. And since I know that the line is y equals a half x plus 3, then y will equal a half times minus 6 on 5 plus 3, which is minus 3/5 plus 15/5, which should be 12/5. So point P is minus 6/5 and 12/5. And that's the answer to the question, because the question asks for what are the coordinates of P when it's a minimum distance.